Good evening everyone. So today we are going to discuss another questions from Acer Green, and this is related to general chemistry. Okay. So here we have some information. So look at this. The ability of an atom that is in a bond to attract electron itself is called electronegativity, and we have a table with the electronegative values. And look at this information. In a covalent bond that is more electronegative will have slightly electronegative charge. Suppose we have A and B. Suppose we have A and B, and I am saying electronegativity of A is supposed to be 4.0 and B, which is 3.5. So according to the system, it is saying more electronegative will be slightly negative. So A is more electronegative, so this is delta negative and this is delta positive. Clear? And the next line is, write the atom that is less electronegative have positive. The bond formed is a dipolar bond. So this bond is a dipolar. The greater the difference between electronegativities, the more polar is bond. Look at here another information. Suppose A has electronegative value 4.2, B has 3.5, and suppose C has 3.0 and D have 3.5. Clear? And I am saying which bond is more polar, AB bond, AC bond and AD bond. So how can we do this? Just figure out the difference of electron negativity. So for AB bond, it will be 4 and 3.5, so 0.5. For AC bond, 4 and 3, so this is 1.2. For AD bond, 4 and 3.5, so this is 1 point. Wait, I think we have the same values of this. Suppose this is 2.5. Yes. So AD is somewhere around 1.5. So most polar will be AD because this one has the highest difference in the electronegativity. Clear? Which is 1.5. So this is all about the polarity and electronegativity. Clear? The second information is, in most organic molecule, the greater electronegative difference occurs most commonly in a bond that have hydrogen atom at one end and one atom of oxygen, means hydrogen, and one atom, it can be oxygen, nitrogen at the other end, oxygen, nitrogen. So this is the most polar one according to this information because that one has the highest difference of electronegativity. In such a bond, the hydrogen atom has slightly positive, yes, because of less electronegative and they are more. And the same molecule are different. The attraction is called hydrogen bond. This type of attraction is a hydrogen bond. Clear? But that should not be the single bond. Attraction is dotted line. Clear? Simple thing is that when we have a hydrogen and we have oxygen, nitrogen as well as fluorine, and this dot line is called hydrogen bond because these are the very electronegative element. Clear? And hydrogen bond are not the stronger as ionic and covalent, but they are much stronger than the dispersion force. Let's move to the question 5. Of the following, the most polar bond will be covalent bond formed between the atoms of. So simply you have to figure out the difference of electronegativity of A. You can see they have fluorine and chlorine. Fluorine is 3.98, chlorine is 3.16. So higher to lower. So which means 3.98 minus 3.16. You have to do this one. And then sulfur and oxygen. Oxygen is 3.44 and sulfur is 2.58. Clear? and the C is phosphorus and nitrogen. Nitrogen is 3.04, phosphorus is 2.19, and the last one is carbon and chlorine. Chlorine is 3.16 and carbon is 2.55. I think B, if you are going to calculate this, B and C are very close. I think 0.21 is the difference, and B has highest, so B is the most polar. I think this is 0.85 somewhere, it's 6, and this is 0.85. You can calculate, it's quite simple. Now move to question 6. In one part of a molecule, there is a carbon-oxygen bond. So we have a carbon-oxygen bond, while in another part there is a hydrogen and nitrogen bond, hydrogen and nitrogen. And now it is talking about attraction. Look at here. Look at the hydrogen bonding. You have to take this hydrogen and the electronegative element oxygen. This is slightly delta positive, this is negative. And this attraction is called as hydrogen bond. Clear? We can discuss here as well. You know, there is a condition for hydrogen bonding. First of all, any compound can show hydrogen bond when hydrogen is directly linked with either fluorine or oxygen or nitrogen. Clear? So if any compound has this type of connectivity, which means it can show hydrogen bond. Clear? This is not a hydrogen bond. This hydrogen has ability to form a hydrogen bond. And how it can be possible? Look at here. Suppose, what is the condition for hydrogen bonding? Look at the condition. This hydrogen must be bonded with fluorine, oxygen or nitrogen. Clear? Now this hydrogen has ability to make a hydrogen bond with another electronegative set of element, which can be fluorine, chlorine, fluorine, oxygen and nitrogen. And this attraction is called hydrogen bond. Clear? This attraction is called as hydrogen bond. So what does it mean? It means we must have a hydrogen which is linked with either fluorine or oxygen or nitrogen, any one of them. And then this hydrogen can form hydrogen bond with another electronegative element, which can be fluorine, oxygen and nitrogen. So you can see here we have this hydrogen and this is another electronegative element. So this dot is a hydrogen bond. Clear? We can discuss another example. Suppose this compound we have. So you can see we have this hydrogen and this is electronegative, another set of electronegative element, which is fluorine, oxygen or nitrogen, anyone. So we have fluorine, so there is a dotted line and this is hydrogen bond. Clear? So here answer will be C. The attraction of hydrogen atom in one bond to the oxygen of another. Clear? Two hydrogen atom formed involving all four atom? No. Because we have only one hydrogen bond. An attraction of nitrogen atom in one bond and oxygen atom in other, it cannot be possible because nitrogen and oxygen both are electronegative, and if you have both electronegative, then there is no hydrogen bonding. Hydrogen bonding is always hydrogen. You know, you have to make a bond with the hydrogen, but it is talking about nitrogen and oxygen. That's wrong. D, repulsion between carbon atom in one bond and the nitrogen atom in the other. It is not possible as well because carbon is here delta positive and nitrogen is here delta negative. So opposite charges they have. So it should be attraction, not repulsion. But this kind of attraction is not a hydrogen bond. Okay. Now look at the question 7. It is talking about the positive charge end of these two bonds would have respectively Cn and sulfur and hydrogen. I think between carbon and nitrogen, electronegativity of nitrogen is greater than carbon, and you can see from table. Look at here. Nitrogen 3.04 and carbon is 2.55. So nitrogen is more electronegative, and carbon and nitrogen we have sulfur and hydrogen. So more electronegative will be delta negative. So here delta negative is nitrogen, carbon is delta positive. And now the next is sulfur hydrogen. So sulfur is here 2.58 and hydrogen is 2.20. So sulfur is delta negative and hydrogen is delta positive. So we can say here this is delta negative, this is delta positive, this is delta negative, this is delta positive. And it is talking about positive set. So positive is this one, the carbon and hydrogen. So answer will be B. Clear? Now the 8th one is, of the following the attractive interaction between atom of two molecules that are the same distance apart would be strongest. So first of all you have to select the right attraction, and the right attraction is what? Hydrogen with fluorine, oxygen or nitrogen. Any one of them. You can see this attraction between oxygen and nitrogen, not possible. Hydrogen and hydrogen only, not possible. Sulfur hydrogen, not possible. Yes, this one is possible, hydrogen and nitrogen. So this will be the strongest. Clear? Quite easy this one is. Now the 9, of the following the factor that has the least effect of the strength of hydrogen bond. Okay, as you know that this is a force of attraction. Force of attraction. Look at here another. This is the hydrogen bond. This hydrogen has ability to form a hydrogen bond with another set of electronegative, which should be fluorine, oxygen and nitrogen. Clear? This is attraction. Delta negative, this is delta positive. So whenever we are using a term attraction, so this is not a bond, this is a force of attraction. So when the charges are closer, the attraction is the highest, and when they are very far, they have very low attraction, which means it depends on the distance. So you can see it is talking about the least effect. So distance is an important factor. So this is not the right. And second, first thing, type of atom to which hydrogen atom is covalently bonded. This is also very important factor. So this should not be the right choice. What is the mean of this? Type of atom. This is the hydrogen atom and this is the type of atom. So this is an important factor, because hydrogen bond water can form but not CH4. They both have hydrogen, but what the difference of their hydrogen? This hydrogen is linked with oxygen, but this is linked with carbon. So it cannot form hydrogen bond, but it can. So that's why type of atom is an important factor. Distance we did. And now the D1, look at type of atom in the other part of the molecule to which hydrogen atom is attracted. So this atom it is talking about, this type. This is also very important. Suppose we have water and methane. So we have this hydrogen for hydrogen bond, but we have to figure out another set of electronegative element which can be fluorine, oxygen and nitrogen. And you can see there is no electronegative element. Can you see? This is carbon and hydrogen only. So there is no hydrogen bond here. But if we have water and ketone, supposed to be, this is water, suppose here we have this ketone. So this hydrogen is available for hydrogen bond, and this is the another set of electronegative element, and this attraction is called hydrogen bond. Clear? So simple thing is that the nature of this element is also important if it is electronegative. then we can form a hydrogen bond. So D is important factor, B is important factor, A is important factor, C is a least effective, least. The number of other hydrogen atom attracted to the atom on the other part of the molecule. There is no mean of it. It's clear? Suppose this carbon has 2 hydrogen. There is no mean of this. We have to only consider the hydrogen which is linked with fluorine, oxygen and nitrogen and another set of electronegative. So this is the least effective thing. So answer should be C, the least effective. So this is from Acer Green and this is question 5 to 9. Clear? Thank you so much for watching this.